Okay, so we're diving into something pretty intense this time. You've got all this material, survivor stories, scientific reports, all about the 2011 tsunami in Japan. And we want to try to understand what really went down that day, like why were so many people caught off guard, and what lessons can we learn about just how powerful nature really is.
Yeah, it's a fascinating collection of sources, and what really hits you right away is it's this clash between our most advanced science and the raw, unimaginable power of the Earth. A real moment where we saw the limits of what we could predict.
So to really get a sense of this, you have to imagine it. A calm Japanese coast, just before 3 in the afternoon, 2:46 p.m. local time, sounds a normal day, and then everything changes in an instant.
It's a stark contrast, isn't it? The way you've put that together. You're suddenly transported from this calm scene to absolute chaos. It shows you just how southern and brutal it was.
It was this. March 11th, 2011, a magnitude 9.1 earthquake, the fourth most powerful ever recorded. Think about that energy being released, but as bad as the shaking was, it was just the beginning, wasn't it?
Exactly. The earthquake caused huge damage over a wide area, but the truly catastrophic part was the tsunami that followed. And one thing that your sources really highlight is this almost unbelievable initial sign, the sea drawing back, receding, as if something massive was about to appear.
It's chilling, right? There's this translated account from a survivor. She describes seeing this dark, wall-like ocean heading towards the shore. Can you even imagine that? It's like some kind of a nightmare.
It goes against everything we normally think about the ocean, and that's a big part of why the scale of the disaster was so unexpected. Our scientific models, the systems designed to warn people and protect communities, they just couldn't handle something this extreme.
That's putting it mildly. A 40-meter wave. To give you a sense of scale, that's taller than a 13-story building, just smashing into coastal cities like Sendai. And the fact that Japan, with its really advanced tsunami defenses, was still so badly hit shows you just how unprecedented this event was.
Yeah.
But the story doesn't end with the wave, does it? Then you've got the catastrophe at the nuclear power plant.
No, it doesn't. The tsunami's impact on the Fukushima Daiichi nuclear power plant added a whole other layer of tragedy and complexity. The sheer volume and force of the water just overwhelmed those critical safety systems and set off a chain reaction of failures.
So in this deep dive, we need to understand, why were those initial tsunami predictions so wrong? How could a wall of water take out a nuclear facility? And the big question hanging over everything, could it happen again? El día que la ciencia falló, the day science failed. That title really gets to the heart of what we're looking at.
It does. And let's start by looking at those very first moments of the disaster. Your sources go through the events minute by minute, and it's gripping. Skyscrapers swaying in Tokyo, but closer to the epicenter, along the Toshoku coast, the ground itself was splitting and shifting.
There's even this sound you included of tectonic plates grinding and breaking. It's a deep, unsettling rumble. Reminds you of the immense forces at work under our feet. And then the J-alert system activates. That's Japan's nationwide warning system. And it broadcasts that chilling warning. Tsunami coming. Evacuate immediately. Gives you shivers just hearing it. It does. And your sources include insights from Dr. Kenji Sato, a seismologist who explains just how much the seabed moved. A vertical displacement of a full 50 meters. To put that in perspective, imagine the ocean floor suddenly rising by the height of a 16-story building. That's the kind of shift we're talking about. He compares it to hitting a bathtub full of water on a planetary scale. That puts it in perspective, yeah. And there's this incredibly powerful account from Akiko Yamamoto in Sendai. She talks about the harbor just emptying out, boats scraping along the bottom.
Yeah.
It was her grandmother who instantly knew it was happening, told her to run for the mountains. That saved her life.
Those firsthand stories are so crucial. They take the scientific data and ground it in the experiences of the people who were there, the sounds you've included, the water dragging cars and debris, the distant cries for help. It's a devastating soundscape of those first moments after the tsunami hit.
Absolutely. It makes you think, what would you do in that kind of situation? But let's go back to the science for a minute. How could the predictions have been so off? We're talking about a predicted 6-meter wave versus the actual 40-meter monster. That's a huge difference.
The key point here, as Dr. Sato explains, is that they underestimated what's called the cosmic slip. That's the extent and duration of the movement along the fault line. The earthquake didn't just hit and stop, it kept rupturing for a full 6 minutes, way longer than the 30 seconds or so that they had built into their models.
6 minutes. When their ground shaking that violently, it must have felt like forever. You've even got this sound in your sources of a computer simulation going crazy, exceeding all its limits, and then this almost symbolic sound of papers being ripped from a board, as if our scientific understanding just couldn't cope with what was happening.
Exactly. The models were based on what we knew about earthquakes in that region, but this one went way beyond anything we'd seen before. It exposed a blind spot in our ability to predict these massive, mega-thrust earthquakes.
And if there was any doubt about the sheer power of this tsunami, you have the audio from the black box of the ship, Matsushima Maru. It's chilling.
It is. You hear the crew in disbelief as the wave towers over them. 40 meters, and then silence. It's a stark audio recording of the overwhelming power of the ocean. And then you find out that the ship ended up 15 kilometers inland. That just shows the unbelievable force involved.
It really forces you to confront the scale of this event. And it leads to a sobering statistic. 90% of the deaths were caused by drowning on the first floors of buildings. People did evacuate, many went to higher floors, but the waves were just so much bigger than anyone imagined. It makes you wonder what evacuation strategies actually work when you're facing something that huge.
That's a critical question your sources raise. Traditional tsunami evacuation plans often focus on vertical evacuation, going to higher levels in buildings. But when you have a 40-meter wave, even being several stories up might not be enough. The volume of water, the force it carries, it can be devastating well beyond the immediate impact zone.
It's the terrifying thing to think about. And then, as if the tsunami wasn't enough, we have the crisis at the Fukushima Daiichi nuclear power plant. The timeline in your sources of those 45 minutes is just agonizing.
It is. The tsunami surge caused a complete loss of power to the plant. It also knocked out the backup generators that were needed to cool the reactors. Engineer Masao Yoshida had to make an impossible decision. Use seawater to cool the reactors, which could damage them in the long run, but might prevent a much worse catastrophe, a full meltdown.
You've even got the actual audio, translated, of the internal communications at TEPSCO, the plant's operator.
Oh.
You can hear the panic rising in their voices as the water levels inside the reactor buildings dropped. The nuclear fuel cores were exposed, and that's incredibly dangerous. And then those sounds, nuclear alarms, the crackling and popping of underwater cables short-circuiting. It's a picture of chaos and a desperate fight against time.
It is, and what's really troubling, as revealed by journalist Mika Kobayashi in your sources, is that there were reports from as far back as 2008 predicting tsunamis up to 15 meters high at Fukushima. But for some reason, TEPSCO seems to have ignored those warnings, and that's something that's still being investigated.
It's mind-blowing when you consider the consequences. There's this sound of archived documents being dug up, and then the sound of someone typing, entering that deliberately low maximum wave height they use in their safety assessments. Just 5.7 meters compared to the 15 meters their own reports had warned about. And the seawall they actually built, only 5.5 meters high. It feels like a total failure to anticipate and manage risk.
It certainly raises serious questions about regulation, corporate responsibility, and the need to take even unlikely warnings seriously when we're dealing with things like nuclear power. The infrastructure was clearly not prepared for a threat that they had been warned about years earlier.
But even amidst all this devastation and those apparent failures, there are also incredible stories of human courage, right? The story of the Fukushima 50?
Absolutely. The actions of those technicians, people like Kazuhiko Yamashita who stayed at the plant, they worked nonstop for 72 hours, facing deadly radiation. They knew what could happen, that Tokyo could become uninhabitable, and they put their lives on the line to try to stabilize those reactors.
The sounds in your sources make their sacrifice so real. The Geiger counter clicking faster and faster as the radiation levels spiked. The sound of coughing, which is just a reminder of the physical effects of radiation. And the radiation dose they received, equivalent to 30,000 X-rays. It's hard to grasp the level of danger they faced.
It really shows how serious the situation was and the incredible courage of those who chose to stay and fight to prevent an even bigger disaster. There's no doubt that their actions prevented an even worse nuclear catastrophe.
And it wasn't just the immediate damage in the nuclear crisis. There seems to have been a real problem with how the severity of the nuclear event was communicated to the world, didn't there?
Yes, definitely. Dr. Sato's clearly frustrated in your sources about how official sources initially downplayed the severity of the nuclear event. It was first reported as a level 4 incident, but later it was correctly reclassified as level 7, the same level as Chernobyl.
And you've included this audio that really drives the point home. It's the Prime Minister's press conference. And he's saying, no es momento de pánico. It is not a time for panic. And then right after that, you hear international news reports in different languages describing it as just a small leak. It feels like a deliberate attempt to downplay the real danger.
It highlights how complex it is to manage information during a major crisis. But it also shows how governments and organizations might try to minimize risks or give incomplete information, and that can have serious consequences for public trust and how the international community understands the situation.
And the danger at Fukushima didn't just disappear, did it? Years later, there's still a large exclusion zone around the plant.
That's right. The exclusion zone is a huge area, and the situation inside the Fukushima Daiichi plant is still a major concern. You can hear the sounds of radioactive water dripping in Unit 2, and then there's this automated AI alert, corium detected under reactor. These are constant reminders of the very real threats that still exist. Corium, by the way, is essentially the melted core of the nuclear reactor, and it's highly radioactive and dangerous.
Corium. And there was something like 900 tons of this molten nuclear fuel. Are we sure it's contained? Is it stable? It's a very unsettling thought.
It's a long-term challenge to decommission the plant and ensure the safety of the surrounding environment. Removing that corium is a huge engineering undertaking, unlike anything we've done before.
So, amidst all the tragedy and these ongoing challenges, what lessons have been learned? Your sources point to some big changes in how Japan is approaching tsunami preparedness.
Yeah, the response has been remarkable, both in terms of infrastructure and early warning systems. Dr. Haruto Fujima, a coastal engineer, explains the new seawalls they've built along the Tushoku coast. They're 18 meters high. What's really interesting about these new defenses is that they have a much wider base. It's not just about height, it's about absorbing the energy of those massive waves, dissipating the force.
That's a key difference, isn't it? Not just building higher, but building smarter. The scale of this project is just huge, 400 kilometers of new walls costing something like $12 billion. And they're built on a 15-degree incline to help deflect the wave energy. That's a massive engineering feat. And the computer simulation you included shows a significant reduction in wave impact, something like 62%. That's encouraging, though you do wonder if it would hold up against another 40-meter wave.
It's an ongoing process of adapting and improving. These new defenses offer much better protection against the kind of tsunamis that our models predict. But we can never completely rule out the possibility of even bigger, less frequent events.
And it's not just about physical barriers, is it? How prepared the population is seems just as important.
Absolutely. Professor Yuki Tanaka talks about the monthly tsunami evacuation drills they have in schools in Sendai. That's so significant. Young children are taught to run to higher ground immediately if an earthquake lasts more than 30 seconds. That kind of automatic response can save lives.
It's such a simple but effective thing to teach them. And you've included the sounds of those drills.
Yeah.
Megaphone, kids running, the countdown timer, and then the automated voice announcing the estimated wave arrival time. It shows a real commitment to preparedness.
And they've also integrated advanced technology into their early warning systems. Dr. Aiko Sato, a seismologist, describes the network of 150 seabed sensors they've installed. These sensors can detect earthquakes and potential tsunamis much earlier than land-based systems, which gives people more time to evacuate.
The audio demonstration you have really shows how sophisticated this technology is. You hear a ping when an earthquake is detected on the seabed. Then the system calculates the tsunami probability and triggers an alert. And then the familiar sound of J alerts going off on people's smartphones. It's a multi-layered system designed to give as much warning as possible.
It's a huge advancement in early warning. But as we've seen, even with the bus systems, the unpredictable nature of these events means there's always going to be some risk and uncertainty.
And even with all the new technology and rebuilt infrastructure, there are these stark reminders of the devastation, those ghost zones.
Yes, places like Rikuzentakata, there's this one pine tree left standing from what used to be a whole forest. It's a powerful symbol of all that was lost. Hearing recordings of temple bells from before the tsunami and then a child asking why their home hasn't been rebuilt, it speaks volumes about the lasting impact on these communities.
And then there's that survivor, Isamu Nakamura. He talks about that lone pine tree where he and his wife used to celebrate their anniversary. Now it's a tourist spot where people take photos, but for him, it's a place where he still hears the screams of that day. It's so moving and unsettling at the same time. And the sound of that annual memorial ceremony on March 11th, it's a collective remembrance of a loss that's hard to put into words.
Those personal stories and the physical scars on the landscape are important reminders of the human cost of these disasters and how long and difficult the recovery process is for the communities affected.
And then there's this small but heartbreaking letter from a 9-year-old girl named Emiko to her father. She lost her birthday photos, and her memory of him is tied to their kotatsu, the heated table. And then she just matter-of-factly explains how she survived by clinging to a floating refrigerator while her father didn't. It's just devastating.
Those small personal details often have a much bigger emotional impact than any statistics. They make us think about the individual tragedies behind the larger story of the disaster.
And lastly, there's grandfather Taikeo from Oshima Island. He remembers past tsunamis, especially the Great Jogan Tsunami of 869 AD. He offers a different perspective on our modern reliance on seawalls, reminding us of the long and brutal history of the sea.
His perspective is really important. It shows us that these massive events have happened before, maybe even on a larger scale. And the geological evidence suggests they'll happen again. It's a reminder that we need to think long-term about coastal risks. We can't just rely on seawalls.
It's a humbling thought, isn't it? These catastrophic events have happened before, and they will happen again.
Exactly. It's a reminder that we need to focus not just on building physical defenses, but also on remembering the lessons of the past. We have to respect the immense and unpredictable power of nature.
So as we think about everything we've explored, that final image from your sources is incredibly powerful. The stopped clock at 2:46 p.m. inside Jakuma Station. It's a permanent reminder of that moment when everything changed.
It is. It's a reminder of the day that science, for all its progress, was confronted by a force of nature it didn't fully understand.
Lo dejaron así, para que nunca olvidemos que la tierra decide. Nosotros solo bailamos al ritmo que nos marca. They left it like that. So we never forget that the earth ultimately decides, and we, as humans, are just dancing to the rhythm it sets for us. That's a really thought-provoking and unsettling way to end this.
It is. It speaks to the unpredictability of our planet and the need for humility and for us to keep learning and adapting in the face of these powerful forces.
Absolutely. Thank you for taking us through this deep dive. It's a sobering but really important story to understand.
I agree.
And to our listeners, we encourage you to delve deeper into this event. Consider what steps you might take in your own life to prepare for the unexpected. Because as we've seen, the Earth always has the final say.
And often she speaks in a voice that's far louder than we expect.
Indeed. Thanks for joining us, and until next time, stay curious. All right, so you're all here because you're ready to dive deep. You want to cut through all that fluff and get right to the core of things.
Absolutely.
And that's exactly what we're about to do. We're tackling a truly monumental event, the 1883 eruption of Krakatoa.
It's one for the history books, for sure. And to guide our deep dive today, we've got something special. A sound documentary called Krakatoa 1883, Cuando el Mundo Explotó.
Wow, that title alone.
It's powerful stuff. And what makes this source so compelling is that it goes beyond the typical historical recounting. It uses sound design, historical accounts. It really puts you right in the middle of the action.
It's like an audio time machine, almost, transporting you back to that fateful day. So just picture it. August 27th, 1883.
The sun to straight.
Probably a calm, typical tropical morning until, well, the Earth basically unleashes this unbelievable force.
Yeah, the documentary doesn't waste any time. Right off the bat, you hear this narration, originally in Spanish, and it sets the stage perfectly.
Let's hear it.
Okay, so it says, 27 de agosto de 1883. En el estrecho de Sonda, un grito de la tierra rompió todos los récords y dejó el primer registro sonoro de un planeta herido. Esto es lo que ocurrió cuando el Krakatoa decidió despertar.
Chills, literal chills. That's some powerful imagery. A scream of the earth.
It really captures the sheer scale of what's about to unfold. And one thing the documentary does really well is it highlights the subtle clues that something huge was brewing even before the major explosions.
Oh, like what?
Well, for example, there were these recordings of infrasound, and it was registering at a super low frequency, like 0.1 hertz. Now, that's way too low for us to hear, but the power of it was undeniable. People in Jakarta, which is over 100 miles away, reported windows rattling.
Wow, so it's like the Earth was giving this low, ominous groan. Something you feel more than here, but it's spreading for miles.
Exactly. It sets up this sense of anticipation, almost dread, of something massive about to happen. And then the documentary shifts to the morning of the eruption itself, and the atmosphere, well, it gets pretty terrifying.
Okay, so paint us a picture. What's happening?
Well, they include this first-hand account from a British sea captain, Captain R.J. Dalby. His diary entries are just chillin'. He wrote, and I'll translate from the Spanish, "The sky turned blood red. We thought it was the end of the world until the water came."
That's heavy stuff.
Yeah.
That image of a blood-red sky, it's like something out of a nightmare. But I guess that was just the beginning, right?
Right. As terrifying as that was, it was just a precursor to the main event. At 10:02 a.m., The volcano erupts with a force that's just mind-boggling.
The documentary actually puts a number on it, right?
Yeah, they say the explosion had the force of 200 megatons.
200 megatons. How do you even wrap your head around that?
It's hard to fathom. To put it in perspective, that's the equivalent of about 13,000 Hiroshima bombs. Just absolutely devastating.
And then the sound.
Yeah.
You mentioned earlier how this documentary uses sound to really immerse you. What was it like?
Well, they capture the sheer distance this sound traveled. Think about it. The sound was heard on Rodrigues Island, which is over 3,000 miles away, and in Perth, Australia, over 2,000 miles away.
Wait, so this sound wave traveled across oceans and continents.
Yeah, and it was still clearly audible. It makes you think about the physics of it all, how a sound wave can maintain that intensity over such vast distances.
It's mind-blowing. And they didn't just capture the big booming sounds, right? There were these smaller, almost eerie details that really stood out.
Oh yeah, like in Batavia, which is now Jakarta, people there reported hearing what sounded like shouts, but in Dutch? Imagine that, over 100 miles away, and you hear these faint, almost ghostly shouts in a foreign language.
Spooky. And get this, barometers in London, thousands of miles away, actually went haywire. Some even shattered because of the pressure wave.
Right, it's incredible. It just shows how this single event had repercussions across the entire globe, and we're still just talking about the initial explosion.
Right, we haven't even gotten to the tsunamis.
Yeah, that's where things get really tragic. The documentary does a great job of capturing the human cost of this disaster. They include a translated account from a Javanese fisherman, and it's heartbreaking. He describes the sea receding, revealing all these fish they'd never seen before, and the children, they run out to collect them, thinking it's this amazing, once-in-a-lifetime event.
Oh, no.
And the fisherman describes it as their last smile.
Oh, that's just devastating. It's such a stark reminder of how quickly things can turn. One moment, it's this strange, almost wondrous event, and the next, it's utter devastation.
And the science behind these tsunamis is just terrifying. We're talking walls of water 30 meters high. That's like a 10-story building.
Wow.
And they were traveling at speeds of 300 kilometers per hour. Basically, no chance of outrunning that.
So what caused these massive waves?
Well, the documentary explains how the collapse of the Krakatoa caldera was the culprit. You see, when a volcano erupts like that, it leaves behind this massive basin-like depression. And in this case, the caldera collapsed beneath the ocean surface. Ah, so it's like a giant underwater landslide?
Precisely.
Yeah.
And that sudden displacement of water is what created these monstrous tsunamis. And they didn't just sweep over the ocean. The documentary has these vivid descriptions of the waves crashing inland, ripping up entire forests like they were nothing. It's a scene of unimaginable destruction.
It sounds apocalyptic. So we've got the initial explosion, these terrifying tsunamis, but the story doesn't end there, right? The documentary talks about the long-term global impacts of this eruption, almost like a volcanic winter.
Right. And here's where it gets even more fascinating, because it shows how interconnected our planet really is. For 3 years after the eruption, people as far away as New York were seeing these incredibly vibrant purple sunsets. And there's even speculation that Edvard Munch's famous painting, The Scream, might have been inspired by those ash-filled skies.
Wow, so this eruption in Indonesia potentially influenced art on the other side of the world. It's a compelling theory. But beyond the visual spectacle, there were real, measurable climatic effects. The documentary highlights how the global average temperature dropped by about 1.2 degrees Celsius for 5 years.
That's significant.
Absolutely. A drop like that can have a domino effect on weather patterns, agriculture, you name it. Krakatoa basically threw the entire planet's climate system out of whack.
And it wasn't just the sunsets and the temperature. The documentary also mentions how European painters, without even realizing it, were capturing the effects of Krakatoa's ash in their artwork.
Yeah, it's like this unintentional global art project. They might not have known what was causing those unusual colors in the sky, but their paintings became a record of this massive atmospheric event.
It's incredible. So we've gone from this localized explosion to these global repercussions. But then the documentary brings us back to the present day, to Anna Krakatau, the child of Krakatau.
It's a stark reminder that this story isn't over. The geological forces that created Krakatoa are still very much active. In fact, the documentary mentions that Anak Krakatau is currently growing at a rate of about 5 meters per year.
So it's like this ticking time bomb slowly rebuilding itself.
And it's not just slow, gradual growth. The documentary reminds us of the 2018 tsunami that was triggered by Anak Krakatau, a tragic event that claimed hundreds of lives.
Right, a sobering reminder that this volcano is a very real threat.
And they drive that point home by incorporating these sounds of Anak Krakatau in the present day. You hear the real-time seismic data, this constant rumbling, and then the waves crashing against its cone. It's both unsettling and captivating at the same time.
It's a powerful way to bring the narrative full circle. So our deep dive into Krakatoa has been quite a journey. We've learned about the unimaginable force of the initial explosion, the devastating tsunamis, and then these global impacts that rippled out across the planet.
And to think, it all started with a single volcano erupting on a seemingly ordinary day.
Yeah.
It really highlights the power of nature and how interconnected everything on our planet truly is.
It's awe-inspiring and terrifying at the same time. So the question for all of you listening is this. Given what we've learned about Krakatoa, both its past and its present, how should we approach our relationship with this planet? How can we better prepare for future events like this? And what does it tell us about our own vulnerability in the face of these incredible natural forces? Something to ponder.
It certainly is.
Thanks for joining us for this deep dive. Until next time, keep exploring.
Keep learning.
And keep asking questions.
We'll see you on the next deep dive. Welcome to the Depth Dive. Today, you and I are going to plunge into the extraordinary story of Lituya Bay, Alaska, back in 1958, and the absolutely colossal wave that it unleashed.
Colossal. Yeah, that barely scratches the surface, honestly. What happened there wasn't just, a big wave. It was on a scale almost beyond imagining.
You're right. We're talking about a wave that reached, what was it, a staggering 524 meters in height.
Yeah.
To give you a sense of that, that's taller than what pretty much any skyscraper you can easily picture.
Right.
And what caused this incredible event, a massive earthquake triggering a truly immense landslide.
Precisely. And for our deep dive today, we have some incredibly compelling material. We're looking at a sound documentary that meticulously pieces together this event using scientific data and some truly gripping firsthand accounts from people who were actually there.
So what we want to do today, for you following along, is to really get our heads around just how unprecedented this event was. To understand the geology and physics involved and to think about, well, whether something like this could possibly happen again.
Okay.
Okay, let's unpack the night it all began.
Right. July 9th, 1958. Picture Lituya Bay. It's this remote and dramatic fjord up in Alaska. You've got these huge glaciers meeting steep, rugged mountains. It's quite a scene.
Definitely.
On that night, a powerful magnitude 7.8 earthquake struck the region.
And this wasn't just a little tremor, was it? Our source has some really powerful audio that helps you sort of experience the sheer force of it. You can almost feel the ground shaking with these deep, rumbling seismic sounds, and then the sound of a mountain literally giving way.
Yeah, the documentary uses recordings similar to the Kolka Glacier collapse, I think, to give you an idea of that raw power. What's fascinating here is the sheer volume of material that was dislodged by that quake. Something like 30 million tons of rock cascading down into the Gilbert Inlet at the very head of Lituya Bay.
30 million tons.
Yeah. And we actually have, believe it or not, a hydrophone recording that captured the moment of that enormous impact as it hit the deep water.
Which, as you can imagine, sent shockwaves through the entire bay. And then the wave. 524 meters high.
Just incredible.
And that measurement isn't just a guess, right? It's based on the very clear scars left high on the mountainsides where the wave literally ripped away the forest. The trim lines, they call them.
Exactly, those trim lines on the mountains. There's such stark visual evidence of the wave's incredible reach. They really tell a story that, numbers alone just can't fully capture.
Yeah. And we also have an absolutely remarkable firsthand account from a fisherman, Howard Ulrich, who was there on his boat, the Idri. His original recording from '58 is part of our source, and when you listen to it, wow, you can hear the sheer terror and disbelief in his voice as he describes the entire forest around the bay seeming to rise up. He said the trees were flying around like matchsticks.
Like matchsticks. And unbelievably, his boat, the Idri, was actually lifted up by this monstrous wave and carried inland at an estimated speed of, 160 kilometers per hour.
160.
And it survived. It's just an incredible testament to the raw power of the wave, and you have to think a fair bit of sheer luck involved there, too.
Absolutely. The documentary uses a really interesting sonar bathymetry sound effect, complete with the Doppler effect, to help us visualize and almost, well, hear the underwater landslide as it happened.
Right, that shift in pitch.
Yeah, the changing pitch in the sonar sound helps us understand the speed and direction of the landslide material moving underwater. It really gives you a sense of the scale and the speed of all that stuff shifting beneath the surface.
And what's crucial for us to understand is exactly how that sudden displacement of such a massive amount of material directly resulted in that colossal wave. The transfer of energy was almost instantaneous and just, on an unimaginable scale.
And to really bring home the sheer destructive force, the documentary incorporates 360-degree audio of 300-year-old trees being uprooted.
Wow.
You can practically hear and feel the ground giving way all around you. It paints such a vivid picture of the utter devastation.
So, okay, we've set the scene, a massive earthquake, an absolutely colossal landslide, and a wave that seems, well, almost impossible. But how do we even begin to understand the physics behind something so extraordinary?
Well, this is where it gets really fascinating. The expert in our documentary, Dr. Herman Fricks, describes this as an impact tsunami.
An impact tsunami, right.
Yeah, you can think of it like dropping a rock into a bathtub, but instead of just a little splash, you're dropping an entire mountainside.
That analogy is really helpful for getting a basic grasp of the principle, yeah. But the actual scale here is just light years beyond your average bathtub splash. Dr. Fritz estimates that the energy released in the Lituya Bay event was equivalent to around 50 atomic bombs.
50 atomic bombs. That's a truly staggering amount of power concentrated in a single brief event.
It really is.
And to help us visualize this even further, our source includes simulated supercomputer data. We even have an AI voice confirming the nonlinear wave model and echoing that incredible height of 524.3 meters.
Ah, the confirmation.
Now, a nonlinear wave model, in simple terms, describes how these massive impact waves behave in much more complex ways than, typical waves because of the sheer amount of energy and the unique shape of the bay.
Right, it's not just a simple ripple.
Exactly. It's fascinating to hear how modern technology corroborates these eyewitness accounts and the geological findings from all those years ago.
That convergence of what people actually saw and experienced with this, cutting-edge computational modeling, it really reinforces how accurate our understanding of this event has become. It's pretty amazing.
Yeah. The documentary also uses a really effective auditory comparison to highlight the fundamental difference between a normal tsunami and what happened at Lituya Bay.
Oh, yeah. How so?
Well, a normal tsunami is likened to the gentle plop of just a few water droplets, whereas the Lituya event is this massive boom of a subaquatic explosion.
Okay. That's a good way to put it.
That stark contrast really drives home the truly unique nature of this impact tsunami.
Exactly. The energy wasn't just the displacement of water like you'd have with the typical tectonic tsunami from an earthquake far offshore. Instead, it was the immense kinetic energy of millions of tons of rock slamming into the water and the seafloor, creating a shock wave that then propagated upwards with absolutely incredible force.
So hopefully a once-in-geological history event, right? Or maybe not. The documentary then pivots to a rather unsettling question. Could something like this actually happen again?
That is the crucial question that naturally arises, isn't it? While Lituya Bay had a very specific geological setup, that narrow fjord, the steep slopes that contributed to the event, there are definitely other locations around the world that share similar potential instabilities.
Our source specifically highlights the fjord of Åkneset in Norway as a prime example.
Ah, Åkneset, yes.
There you have an estimated 120 million cubic meters of unstable rock just hanging precariously above the fjord.
120 million. That's 4 times the Lituya slide, roughly. And the potential consequences there are really significant. Scientists estimate that if a collapse of that scale were to occur, it could generate a tsunami up to 80 meters high.
80 meters!
Which could have absolutely devastating impacts on nearby coastal communities, including potentially a major city like Bergen.
Wow. The documentary includes some rather chilling sounds from Norway. The rhythmic beeping of crack sensors that are constantly monitoring the very subtle movements of that unstable rock face.
Constant vigilance.
It serves as a really constant reminder of the potential danger. We also hear a simulation of an evacuation in Geirangerfjord,
Yeah.
which really brings that hypothetical threat into stark and, frankly, unsettling reality.
Yeah, those sophisticated monitoring systems are absolutely vital for providing early warnings if something were to happen. But the real challenge, lies in accurately predicting exactly when a collapse might occur. It's a really complex balancing act of constant risk assessment and trying to maintain a state of preparedness.
And it's not just Norway, is it? The
Yeah.
threat isn't limited to just that one location.
No, not at all.
The Swiss Alps are also mentioned in our source, specifically the potential for a significant collapse of Monterrey into Lake Geneva.
All right. While perhaps not on the exact same massive scale as Okernes said, a substantial landslide into a densely populated lake like Lake Geneva could still generate a very significant and potentially dangerous wave. The specific topography and geology of many mountainous regions often create these kinds of unstable slopes.
It really is sobering to consider that these kinds of risks, while they might be relatively low in terms of probability, carry the potential for truly catastrophic consequences when they do occur.
It is indeed. And this brings us to the final part of our deep dive, where the documentary kind of broadens its focus to look at present-day geological activity as a sort of ongoing reminder of the powerful forces at play.
The specific example given in the documentary is the current situation in Greenland, where a glacier roughly the size of Manhattan has very recently calved.
Manhattan size, that's just immense.
An immense amount of ice breaking off and entering the ocean.
Now, while this particular event isn't going to directly cause a megatsunami in the same way as the Lituya Bay landslide, obviously, these kinds of very large calving events do contribute to global sea level rise, and they really highlight the incredibly dynamic and, well, often unpredictable nature of our planet's geological systems.
We actually have an underwater sonic recording of that iceberg as it falls into the sea in our source. It's a really deep, resonant sound. It truly underscores the sheer mass and the immense power involved in these kinds of natural processes.
It's a stark reminder, isn't it,
Yeah.
that the Earth is constantly in motion and undergoing change, sometimes in ways that are very dramatic
Yeah.
and can potentially be hazardous.
And the documentary ends with a rather unsettling moment. After about 30 seconds of complete silence, there's this sudden AI voice that simply states, "Warning, landslide detected."
Oof, yeah.
It's a really chilling way to leave you with a sense of immediacy and, well, the potential for danger.
That stark, unexpected warning at the very end really serves as a powerful punctuation mark, doesn't it?
Yeah.
Strongly emphasizing that these immense geological forces are still very much active and at play around our world.
So to bring it all together, to summarize our depth dive today, the 1958 Lituya Bay megatsunami wasn't some kind of myth or legend. It was a real, scientifically documented event of truly unimaginable scale.
Definitely real.
And it was triggered by a very specific and absolutely massive geological event, that enormous landslide caused by the earthquake.
And it's so important to remember Dr. Fritz's key description. This was an impact tsunami, which is fundamentally different from the more typical tsunamis we hear about.
Right.
And it released an amount of energy equivalent to the detonation of around 50 atomic bombs.
Mm-hmm.
That's a scale of energy that's almost too vast for us to truly comprehend.
It really is. And perhaps most significantly for us to consider, the documentary makes it clear that the potential for similar events does exist in other geologically active regions around our planet, specifically mentioning the unstable slopes in Norway and in the Swiss Alps as notable examples.
Yeah, those locations serve as a powerful reminder that even though the probability of another megatsunami might be relatively low, the potential consequences are so incredibly severe that ongoing monitoring efforts and, state of preparedness are absolutely essential.
Which brings us to that final, really provocative thought posed by the documentary's narrator. With significant geological events like that massive glacier calving happening right now in Greenland, are we truly paying close enough attention to the Earth's inherent instability and its potential warnings?
That's the lingering question.
It really makes you think about the implications of such profound geological power and whether Lituya Bay was just a truly unique anomaly or perhaps a glimpse into the raw and immense power that our planet is always capable of unleashing.
A sobering thought to end on.
Indeed. Thanks for taking this deep dive with us.
Welcome to the Deep Dive. You sent us something really powerful to explore today, a podcast documental called 2004, El Dique que el Océano Enloqueció. which translates to 2004, the day the ocean went mad. So our goal here is to really, dig into this very immersive audio experience and pull out the key insights for you.
Exactly. It's this incredibly rich piece of audio, and, well, we want to dissect it, understand the fundamental bits, the sequence of events, those personal stories that are woven throughout.
Yeah.
Those moments where maybe looking back, you see the warning signs and the lasting impact this whole catastrophe has had.
Okay, so let's set the scene a bit. December 26, 2004. Across the Indian Ocean for, well, so many people. It was just the start of a normal day, probably a holiday for many.
Right.
And the documentary, it starts by really putting you there, doesn't it? This peaceful soundscape, you hear the gentle waves in Phuket, the happy sounds of tourists enjoying themselves. It gives you this really strong sense of calm.
It really does.
Yeah.
But it's a deceptive calm, as the narrator points out almost immediately. Because underneath all that tranquility, something massive, geologically speaking, was happening. The doc draws our attention right to the moment seismographs. At the USGS, the United States Geological Survey picked up a 9.3 magnitude earthquake just off the coast of Sumatra.
9.3, that's huge.
It was immense, an absolutely immense release of energy. And it happened because two tectonic plates, which had been locked together for maybe 400 years, they finally shifted.
400 years, wow. All that pressure building up, it gives you a sense of just the sheer scale of this thing.
Definitely.
And right from the start, the documentary hints at the devastating consequences that would spread out from there. It really frames it not just as a natural disaster, but as a human story, too. The surprise, the total unpreparedness.
And that's exactly where the documentary takes us next, into a section they call the fatal 15 minutes. It jumps straight from that massive quake to the almost unbelievable speed the disaster hit the coastlines.
Okay, let's unpack that timeline then. The earthquake hits, 9:3 a.m. local time. Then, incredibly quickly, just 45 minutes later, 10:15 a.m., the first monster wave, they say, 24 meters high.
24 meters, yeah. Unbelievable height.
It slams into Ace, and then by 11:00 a.m., beaches in Sri Lanka, Thailand, just completely overwhelmed in such a shockingly short amount of time.
It really is. And what's particularly striking, what the documentary really emphasizes, is the almost total lack of an effective tsunami warning system in the Indian Ocean back then.
Right.
Dr. Carrie C. makes this crucial point. The Pacific Ocean, well, it already had infrastructure, to detect quakes like this, maybe issue warnings. The Indian Ocean just didn't have that safety net.
It's almost hard to grasp, isn't it, that satellites could actually see the wave forming traveling across the ocean.
Yeah, they observed it.
But there wasn't a reliable way to get that warning to the people literally on the beaches. The documentary uses these really haunting sounds to highlight this failure. You hear distorted recordings of attempted calls, like between NOAA, the National Oceanic and Atmospheric Administration, and embassies.
Yeah, those failed calls.
And then this deeply unsettling recovered audio, supposedly of the wave actually hitting Khao Lak. You can almost feel the power of the water just from the sound.
It's a really stark illustration, isn't it? How vulnerable people are when those crucial early warning systems just aren't there for these rapid onset disasters.
Definitely.
But, amidst all this tragedy, the documentary also shines a light on these extraordinary examples of human bravery, quick thinking, in a section they call the Angels of the Tsunami.
Ah, yes. These stories are amazing. Take Tilly Smith, this 10-year-old girl, on holiday in Phuket. She actually recognized the signs, the water pulling way, way out, bubbling near the shore, like a boiling pot, they said.
Yeah, the description is vivid.
Because she'd learned about tsunamis in a geography lesson. And her just recognizing it, shouting, "Tsunami!" over and over. They credit her with saving about 100 people. It's just incredible how knowledge can literally save lives.
Absolutely incredible. And then there's Wichin Pomphit, remember him, the park ranger in Thailand.
Oh, yeah, the ranger.
He guided tourists up to higher ground, and his observation about the palm trees bending over like spaghetti, it just vividly conveys the immense force that was coming.
Wow. Like spaghetti, that paints a picture.
It does. These people facing just unimaginable fear and chaos, they acted decisively. Saved others.
And the documentary also weaves in these incredibly moving, very personal audio bits. You hear children singing in an orphanage in Banda Aceh just 2 days before it hit.
Oh, that was heartbreaking.
And then this recreated dialogue, apparently based on survivor accounts, of a mother and daughter clinging to a mattress. It really serves as this potent reminder of the huge human cost, the individual tragedies behind the big numbers.
It's such a vital contrast to the more sort of technical discussion about seismographs and warning systems. These personal accounts, they really ground the enormity of it all in human experience. So following that, the documentary then shifts focus a bit, looking at what might have been overlooked beforehand in a section called Hindsight and Missed Clues.
Yeah, this part is really thought-provoking. We learn about these, like, subtle, maybe almost unnoticed signs that, looking back, could potentially have hinted at something. Like animals in Yala National Park in Sri Lanka apparently fleeing inland like 72 hours before the wave.
72 hours. 3 days.
And artesian wells in India suddenly drying up a whole day before, 24 hours prior.
And what's really interesting there is the exclusive interview bit with Dr. Jane Canine. She talks about fishermen reporting seeing strange earthquake lights in the sky the night before.
Earthquake lights, I hadn't heard of that.
Yeah, apparently. And while the science maybe isn't fully settled on exactly what they are, the key point is that these observations, they weren't connected to any potential danger back in 2004. It just underscores this lack of public awareness, and no real protocols for what to do if you did see something unusual.
Exactly. It wasn't just about the lack of, like, fancy tech warnings. There was also this big gap in public understanding. No clear guidance for people, even if they noticed something weird.
Right.
These little signs, maybe ignored or not understood, they might not have been definitive on their own, but looking back collectively, they kind of suggest missed opportunities for at least some earlier awareness.
Which then naturally leads into the final main section of the documentary, doesn't it? A world changed. Looking at the legacy, the positive changes that came out of it all.
Yeah, it's actually quite a powerful testament to, well, human resilience and the crucial lessons learned, even though it came through such immense tragedy. The documentary details how the Indian Ocean tsunami warning system was set up in 2006. It includes this network of 148 DART buoys, deep ocean assessment and reporting of tsunamis buoys.
Right, the DART system.
These things detect pressure changes way down in the deep ocean that indicate a tsunami. And also, the use of SMS alerts to get warnings out fast. That's a huge step forward in being prepared.
Absolutely, a massive technological leap for the region. And what's also really encouraging, I think, is the increasing recognition, the integration of indigenous knowledge.
Oh yeah, that was
The
fascinating.
documentary highlights the Moken people in Thailand. They have this ancestral knowledge, these traditional ways of reading the sea, recognizing signs of danger.
Right.
And that wisdom is now being incorporated alongside the modern tech. It shows that traditional knowledge can be incredibly valuable. It's not just about buoys and satellites.
Yeah, combining the old and the new. And we even hear what the documentary calls sounds of progress, like an actual real-time tsunami alert from 2012.
A real alert.
And a recording of a school in Thailand doing an evacuation drill. It really brings it home that these systems aren't just plans on paper. They're being used, practiced. Communities are preparing.
It's tangible proof, isn't it, that the hard lessons from 2004 have been turned into real-world improvements. Better preparedness, better response capabilities.
Definitely.
And the documentary wraps up with this very poignant, very reflective epilogue, the Monumento Sonoro, the sound monument.
Ah, yeah. That was incredibly moving and somber. It's an AI voice reading the names of victims in loads of different languages, Indonesian, Thai, Swedish, many others. And it's layered with this binaural mix of ocean waves recorded across all 14 affected countries.
Binaural audio, yeah. So if you listen with headphones, it gives that 3D sound effect.
Right. It's just this incredibly immersive, respectful way to acknowledge the staggering scale of the loss of life.
It really leaves you with this profound sense of the devastation. And then right at the end, the documentary poses this really direct, really crucial question aimed right at the listener. When the next big one hits the Mediterranean or the Caribbean, will we remember the lessons of 2004?
It really makes you stop and think, doesn't it?
Yeah.
Based on everything we've just gone through in this deep dive, how prepared are other vulnerable regions, the Med, the Caribbean, other places? Have we truly learned those lessons and applied them everywhere?
And maybe the biggest lesson isn't just about the technology, the warning systems, as vital as they are. It's also maybe equally about public education, right?
Right.
Getting people aware of the natural signs, fostering this global culture of just being prepared, being ready to respond quickly at every level, individuals, communities, governments, international groups.
Exactly. So as you think about this deep dive into 2004, El Día que el Océano enloqueció, maybe consider, what individual steps could you take to be more informed, more prepared for potential natural disasters, whether that's where you live or when you travel? It's a sobering thought, definitely, but it's one that this powerful documentary really compels us all to think about.
You know how some stories just grab you and won't let go?
Mm-hmm.
The audio documentary you shared, Cascadia La Bomba de Tempo Geologica, it really did that. Kicks off with this, well, really unsettling thought. Sometime between tonight and the next 50 years, the west coast of North America will live its worst nightmare. And scientists can only give us one certainty: it should have already happened. Kind of makes you think, right?
It absolutely does. And what's so effective about this documentary, for you listening, is how it uses sound.
Mm-hmm.
And even some like interactive seismic tech to make the science feel less abstract,
Yeah.
more like a very real, potential event.
Yeah.
It's sort of designed to give you a sense of the scale we're actually talking about.
And that's precisely what we're diving into for you. We've gone deep into this 70-minute audio experience. It's got insights from experts like Dr. Chris Goldfinger from Oregon State and Dr. Yume Wang. She's a geotechnical engineer, someone who really, really understands how the ground itself behaves.
Nice. The mechanics of it.
Exactly. Our goal isn't really to cause alarm, but to pull out the essential information so you can understand the science behind this geological time bomb in the Cascadia subduction zone. We'll look at what could happen, how ready the region is, and even some of the, proactive steps being taken. So let's get into it. This monster, as Dr. Goldfinger calls it, what exactly is it? In terms that help us, understand the risk.
Okay. Well, at its core, it's the Cascadia subduction zone. Think of it as a massive crack, basically, in the Earth's crust. It stretches about 1,100 kilometers, so like 700 miles, from Northern California all the way up past Vancouver Island.
Wow.
Now, what's crucial for you to understand is this isn't just one spot. It's one long connected zone, kind of like a zipper maybe. When it goes, a large section, or, well, potentially the whole thing, could rupture.
Okay.
This zone is where the Juan de Fuca plate, that the section of the Earth's crust under the Pacific, is slowly sliding under the North American plate, the continent we live on.
Okay, so it's like two conveyor belts meeting, and one is trying to go underneath the other, but they get stuck.
Exactly. They get stuck. And the documentary mentioned that the last time this stuck zipper suddenly released was way back in January of 1700.
Yeah, that feels like ancient history.
It does, right?
Yeah.
But that's exactly why scientists are paying such close attention now. The geological record, stuff like evidence of sudden coastal flooding, land dropping. Suddenly it tells us that these massive ruptures have happened repeatedly, over centuries. Roughly every 300 to 500 years, give or take.
So we're in that window.
We are definitely in that window, the 1700 event. It was so powerful it sent a tsunami all the way across the Pacific, hit Japan. They actually have records of it.
Wow, no way.
Yeah, and for you to really grasp the scale, the energy that's been building up since then,
Yeah.
It's just immense. The documentary compares it to about 1,800 Hiroshima bombs.
Whoa.
That's the force we're potentially dealing with.
That comparison, yeah, that really hits home. So when all that stored energy finally releases, what picture does the documentary paint for us? It wasn't a pretty one.
No, it wasn't. Based on scientific models and what we know about past events, a full rupture of the Cascadia subduction zone would likely trigger a magnitude 9.0 earthquake.
A 9.
A 9. Now, for you to understand just how big that is, think of it as being at the very, very top of the earthquake scale, the kind of event that can cause just catastrophic damage over a huge area.
Right, not like the smaller shakes people might be used to.
Not at all. And it won't be a quick shake either.
Yeah.
Dr. Goldfinger highlights that it could last for a full 4 minutes.
4 minutes.
Imagine the ground violently shaking for that long. What would your immediate reaction even be?
I honestly can't imagine 4 minutes of that kind of intensity. And then on top of the earthquake, there's a tsunami. The timeline the documentary lays out is just terrifyingly fast.
It is. The simulations suggest that massive waves could hit the coastline incredibly quickly. We're talking potentially just 15 minutes after the earthquake starts.
15 minutes.
15 minutes when a 12-meter high wave that's like 40 feet could crash into the Oregon coast. For people in those coastal communities, that leaves very, very little time to react.
Barely time to grab anything or figure out where to go.
Exactly. 20 minutes later, Seattle could be under 3 meters, maybe 10 feet of water. And within about an hour, the tsunami would have traveled across the Pacific, potentially affecting communities thousands of miles away.
Wow.
The documentary even includes this chilling scenario where major transportation routes like the I-5 corridor could become unusable, basically cut off.
Yeah, they called it a floating tomb. That image is deeply disturbing.
And hospitals might be cut off for days. Think about how that would impact your access, to essential services.
It really shows how widespread the impact could be, right? Affecting not just those right on the coast. Even Portland, which is inland, is shown experiencing building collapses right at the moment the earthquake hits, just from the intense shaking.
Exactly. The earthquake itself will cause immense damage far beyond the immediate coastline. Bridges could fail, power lines could come down, and, well, any buildings not designed to withstand that level of shaking,
Yeah.
especially older structures, they'll be at significant risk.
Which leads to a really important question, I guess, for you to consider. Given this very real and, well, potentially imminent threat, how prepared is the region to handle something like this?
And that's where the documentary takes a really sobering turn, highlighting how many areas are, frankly, surprisingly unprepared.
Yeah, the statistics they present are genuinely concerning. Like, in Washington's coastal inundation zone, they found that 1 in 3 schools lacks adequate evacuation plans.
1 in 3.
That's a huge number of vulnerable kids in potentially immediate danger.
It really underscores the difficulty, doesn't it? Preparing for what's called a low-probability, high-consequence event. It can be, well, challenging to prioritize resources and attention when the last major event was over 300 years ago.
Out of sight, out of mind, sort of.
Kind of. And the fact that only around 12% of buildings along the coast are considered tsunami-ready. That further illustrates the scale of the preparedness gap. What kind of buildings do you think you typically see along the coastline?
Mostly homes, small businesses, maybe some older hotels or infrastructure. Yeah, it definitely paints a picture of vulnerability. And then there was that report from Newport, Oregon about evacuation signs that lead to cliffs with no stairs down.
Right.
It's almost absurd, but tragically so. It really highlights a potential disconnect, maybe, between simply acknowledging the risk and having actual functional safety measures in place.
Totally. And the sound of that failed elementary school evacuation drill in the documentary, you could hear the confusion, the lack of clear guidance. It was deeply unsettling.
Yeah, it really was.
Those examples really bring the abstract threat into sharp focus for you, don't they?
Yeah.
It's not enough to just draw evacuation routes on a map. They need to be practical, clearly marked, and lead to genuinely safe, high enough locations.
Right. Not just away from the water, but up.
Exactly. And for you and everyone in the region, knowing what to do the moment the ground starts shaking is critical. That instinct to run outside might be the wrong one if you're in a tsunami zone. Getting to higher ground immediately is the priority.
Okay.
The documentary also points out that even existing infrastructure, like, say, 5-meter-high seawalls, about 16 feet, would be completely overwhelmed by a potential 15-meter, 50-foot tsunami wave. So it might seem like a protective barrier offers, well, pretty much a little safety in this scenario.
It definitely paints a concerning picture of our overall readiness. But thankfully, the documentary also sheds light on some proactive efforts, offering what they call glimmers of hope. What are some of those examples of people and communities taking action?
Yeah, it's important for you to know that not everyone is just standing still. There are definitely communities and individuals who are taking this threat very seriously. The story of the Quileute tribe in Washington state is a really powerful example. They made the incredibly difficult but ultimately, forward-thinking decision to relocate their entire village to higher ground, recognizing the long-term danger to their ancestral lands in the potential inundation zone. That kind of large-scale planning and commitment is truly significant.
Absolutely. That takes incredible effort and, well, foresight. And then you have more individual, almost quirky examples like the Toka Tea Club bar that reportedly has lifeboats on its roof.
Yeah, it's a bit unconventional, right?
Yeah.
But it shows a certain level of awareness and, I guess, a willingness to think creatively about survival. What does that kind of ingenuity tell you?
Well, it highlights that preparedness can take many forms, I suppose, and that sometimes the most effective solutions are locally driven, maybe.
I think so. The documentary also points to the increasing role of advanced technology. For instance, the latest generation of dart buoys deployed out in the Pacific, they're designed to provide much earlier and more precise tsunami detection.
Okay, so better warning systems.
Potentially, yeah. And the development of aquatic rescue drones being prototyped in areas like Astoria, Oregon, that offers a glimpse into how technology could be used in search and rescue operations after a major event. These advancements could provide crucial extra time for warnings and response.
And I found the Quileute tribe's alert system particularly fascinating, this blend of traditional drums alongside a modern siren.
That was interesting.
It's a really thoughtful way to combine their cultural heritage with contemporary warning systems to ensure they can reach as many people as possible. What's the benefit of having such a dual system, you think?
Well, for you, the key takeaway there is probably the importance of redundancy and cultural relevance in emergency communication. Relying on just one single method can be risky, right? Especially when infrastructure might be damaged.
Yeah, cell towers down,
Yeah.
power out.
Exactly. The tribal system recognizes the value of both time-honored traditions that are deeply embedded in the community and modern technology for broader reach. It's a very smart and, adaptable approach.
So if we bring it all together for you listening, we have this massive fault line, Cascadia, that's, well, due for a major slip. The potential consequences are devastating. A huge earthquake followed very quickly by a massive tsunami, impacting not just the immediate coastline, but potentially areas far inland and even across the Pacific.
Hmm.
And while there are definitely encouraging signs of proactive measures in some communities and through technological advancements, there's still a significant gap in overall preparedness across the region.
That's a concise and pretty accurate overview, yeah. The geological clock, as the documentary's narrator emphasizes, is ticking. A rupture is inevitable, although the exact timing remains uncertain. It could happen tonight, or it could be, many years from now. But the scientific understanding is clear. The conditions are there, and the stress is constantly building.
And they leave you with this very direct and stark warning at the end. When the alarm sounds, remember, you have 15 minutes to run to 30 meters of elevation, 15 minutes to get to safety. That really underscores the immediate danger of a near-source tsunami.
It does, and the very final moment of the documentary is quite impactful for you to consider. After presenting all this information, all these potential scenarios, they end with this abrupt silence, followed by a simulated emergency alert.
Yep.
This has been a test message from the alert system. It's designed to make you pause and really think about what you've just heard.
It really is. And that leads us to our final thought for you today. Knowing what you now know about the Cascadia subduction zone, its potential for a catastrophic event, and the, well, current state of preparedness, does that test message at the end of the documentary feel like just a routine drill? Or does it feel more like a very real scenario demanding your attention and perhaps even some personal preparation, regardless of exactly where you might live in relation to such potential events? We encourage you to maybe take some time to consider the implications and perhaps explore the emergency preparedness resources available in your own local area. It's definitely a conversation worth having with yourself, with your loved ones, and even just a little bit of preparation can make a significant difference.